So before starting with the demo, we need to make sure that we have a working setup and working environment. So the first step would be to install the Bitcoin core. And after installing it, we can verify that we have successfully installed it by running the following two commands. And if the output is matching the following output, that means that we've successfully installed it. Then depending on the underlying operating system, we need to navigate to one of the following folders. Because I'm on macOS, I will navigate to this folder, and here I need to open bitcoin.conf and edit that file. Here we have the file, and we can modify the username and password to our liking. I will input my name just to showcase the change. After configuring the username and password, we can proceed to run bitcoind. And we can see that bitcoind is successfully running. To verify that bitcoind is successfully running, we can execute this command, for example, and we can see that we are getting some data back. The next steps that we need to take are basically configuring a wallet that we'll be using. So we can navigate to the project root and open the .fn file. Right here we can make the necessary changes that we configured in bitcoin.conf. After making the necessary changes, we can exit and source the environment so that the updated configuration is used. And we can proceed to create a wallet. After creating a wallet, we can load the wallet, even though when we are creating a new wallet, then the wallet is automatically loaded. We can then proceed to generate a few blocks in order to fund the wallet with some BTC, because the Coinbase transactions are going to the default wallet. We are generating 102 blocks because after generating 102 blocks, when getting the balance, we can see that the wallet was funded with 100 BTC. And the reason behind this is because there is this concept of maturation of Coinbase transactions. So 100 blocks need to pass in order for a Coinbase transaction to be usable. So that is the reason why only 2 Coinbase transactions are recorded and reflected on the user's balance. After configuring the Bitcoin core and creating a wallet, the following thing that we need to do is configuring the demo parameters. That is done in config.json. And the configuration that we can do is to modify the listener interval, which reflects the number of seconds that the BTC monitor is going to wait to listen for new blocks. The IPC finalization parameter, or the number of blocks that we need to wait in order to treat an IPC command finalized. Then we have the checkpoint interval and postbox interval, which are the intervals at which the relayer checks the postbox or submits a checkpoint for a particular subnet, is specified in number of seconds. After modifying this config, we can proceed to execute the demo. And in order to execute the demo, we need to set up 4 terminal windows and make sure that you have navigated to the project root. So in the case that bitcoind was unintentionally stopped at the previous step, we can open another terminal window to start bitcoind using the same command that we used previously. And we can close that terminal window. Then we can proceed to run some binaries like the BTC monitor, for example, which is going to be listening for new blocks on the network and therefore detecting IPC commands. And additionally, we need to run the L1 manager CLI, which is our interface toward IPC, or like allowing us to create subnets, join subnets, deposit subnets, and all in all, just interacting with the system. Then we'll proceed with the demo for creating a subnet. But before creating a subnet, I'd like to load the balance of the current loaded wallet. And we can see that we have roughly 150 BTC. Moving on to the L1 manager, we can press 2 for the create child command, and then we'll be prompted to enter a few configuration parameters for that particular subnet. For example, we need to enter the required number of validators, which I'll specify as 1. Then we'll be prompted to enter the required collateral, which each validator joining the particular subnet will need to lock in order to participate in the network. I'll set this to 1 BTC. And then I'll be prompted with a confirmation message. And this is the reason behind the confirmation message, because I might make a mistake that I want the validators to lock 10 BTC instead, but I will enter a key plus enter to cancel this, and then I'll restart the whole process. So I'll enter 1 as the required number of validators, then 1 BTC as the required collateral. Then I'll press enter to confirm this number, and then I need to enter the required initial subnet funding that each validator will contribute to the subnet. This needs to be between 1 and 50 Bitcoin for usability reasons. This initial funding of the subnet is going to be used to pay for transaction fees that the subnet is sending to the network. So I'll set this to 5 BTC. And I'll also get a confirmation message stating whether we are sure that we want the initial funding to be 5 BTC for each validator. I'll enter yes as I am sure. And then the code submits 2 transactions to the network. One is the commit transaction, and one is the reveal transaction, revealing the data on the network. On the left, we can see that the BTC monitor detected the create command and that it was successfully executed. When looking at the L1 manager, we can read the state and see that we have indeed created one particular subnet. When looking at the balance of the user, we can see that it has incremented by 50 BTC, but it also has it reduced for some satoshis. And the reason behind this is something that we previously mentioned, that although the user gets the Coinbase transaction, which also includes the transaction fees, the user needs to wait for 100 blocks in order for this Coinbase transaction to mature and for it to be usable. So essentially the Coinbase transaction that the user got now is from 100 blocks ago. Then we can proceed with the join child demo. Now we can continue with the join subnet demo. Similarly to before starting the demo, we can query the balance of the wallet. And then we can move to the L1 manager to start executing the join subnet command. When after inputting 3 to trigger the join command, we are prompted to pick a subnet that we want to join. Since we have only one choice, we enter 1, and then we're going to be prompted with some configuration parameters that we need to enter for the particular validator joining. So first we need to enter the validator's IP address. Then we need to enter the validator's BTC address, and this address is going to be used to return the collateral after the subnet is deleted to the validator. So we are going to fetch a new BTC address from the Bitcoin CLI. And in the end, we need to enter the validator's name, which I'll enter as validator. In the end, we are going to be asked to confirm that we want to lock 1 BTC as collateral and contribute 5 BTC as initial funding as validator, which are the parameters that we configured when creating the subnet. After pressing enter, we can see that similarly to create child, 2 transactions are submitted. One is to commit to the data, and the second transaction is to reveal the data on chain. On the left, on BTC monitor, we can see that indeed join command was detected, which contains the configuration parameters that we specified, and that it was successfully executed. If we read the state, we can see that we have the same subnet, but now it contains a validator that joined the subnet. If we look at the balance of the user, we can see a similar thing happening. So 50 BTC from the Coinbase transaction got into the user's wallet. Then 6 BTC are subtracted, because 1 for the collateral and 5 for the initial funding. And then some Satoshis are also subtracted to pay for the transaction fees for the joint child transaction. So after successfully creating and joining a subnet, we'll proceed to follow the same process to create and join another subnet in order for them to be able to interact with each other. So we'll follow essentially the same process. We'll enter 2 to prompt the create child command and enter the required parameters. We'll set 1 BTC as the required collateral and confirm this, and additionally set 10 BTC as the required initial funding per validator. After confirming this, we see the 2 transactions again, and then we can see that the following subnet got created. Then we can proceed to join this subnet in order to fund it. Generate a new BTC address for the validator and enter the validator name. After the confirmation, we can see that again 2 transactions got submitted, the commit and reveal for the joint child. And on the left, on the BTC monitor, we can see that the changes are reflected. After reading the state, we can see that both subnets now contain a validator. After creating and funding the subnets, we can proceed to launch the subnet interactor for each of the subnets and create some accounts. So in order to do this, we need to run the subnet interactor. And to run the subnet interactor, we need to specify the subnet ID. After executing this, we can see that the simulator was both the simulator and subnet interactor were started for this particular subnet. The options that we have on the subnet interactor are creating an account, transferring funds, whether that is within the subnet or maybe to potentially another subnet, getting the checkpoint of the state, withdrawing funds, deleting the subnet, and also printing the state. If we print the state, we can see that here we have some information about the subnet, then the validators, and as well as the balance of the subnet. And this balance comes from the values, the collateral that was locked by the joining validators, and also the initial funding that was also sent to the subnet by the validators. Then we can proceed to create an account by pressing 1, and we can specify a Filecoin address as the account address. And we can also create another account with an address that's slightly modified compared to the first one. When printing the state, we can see that the two accounts were created with 0 balances, essentially, because we need to deposit some amount in order for the accounts to be funded. We can also open the subnet interactor for the second subnet. And proceed to create an account here named maybe target. And when printing the state, we can also see that this the balance of this subnet is 11 because 1 was locked as collateral and the 10 BTC is the initial funding used to cover fees. We can see that target account was successfully created. Then we can continue with depositing some BTC to a particular account on a subnet. And in order to do that, we'll first get the user balance, similar to before. We can see that we have roughly 330 BTC. So moving to the L1 manager, we press 4 in order to deposit to a particular subnet, and then we are prompted to choose a subnet that we want to deposit to. Since I have the subnet interactor open for this subnet, that is the subnet that I'll deposit to. In order to enter the amount that I want to deposit, I'll deposit 2 BTC. I'll be prompted with a confirmation message asking whether I'm sure that I want to deposit 2 BTC. I'll press enter to confirm that. I'll specify the following address as the target address on the subnet that I want to deposit to. And by pressing enter, I can see that the transaction was submitted and the block was mined. On the left, we can see that the particular account was successfully funded and that the deposit command was successfully executed. If we take a look at the wallet balance, we can see that it increased by 50 BTC because of the Coinbase transaction, and it reduced by 2 BTC because that's the amount that we deposited to the subnet. And additionally, similarly to before, decreased by a certain amount of satoshis in order to pay for the fees for the deposit transaction. If we take a look at the subnet interactor, we can see that the state updated, having this account 2 BTC, and the total subnet balance got updated, and the total withdrawable amount by users is equal to 2 BTC because that's exactly the balance of one of the users on the subnet. Yeah, we can proceed with the transfer demo after this. We'll now proceed with the demo for the transfer functionality. In the subnet interactor, if we press 2, we can transfer funds, and there are 2 types of transfers that we can do. One type is inside of the subnet. So, for example, this account can send some funds to that account, and this will execute right away on the simulator. And alternatively, we can make a cross-subnet transfer. That is that an account from this subnet is sending some funds to an account on another subnet. And so initially we can start by pressing 2. So here we have a disclaimer that currently there are no fees implemented on the subnet itself. So the whole amount is transferred to the destination. Of course, in the future, the fees would be added to cover the transaction fees sent by this subnet to the Bitcoin network. If we specify the from address, for example, this one, for the target, for the target address, we can specify the other address, so make a transfer inside of the subnet, and the amount can be set to 1 wrapped BTC. And we're going to be prompted with a confirmation that whether we are sure to make this transfer. After accepting this, and printing the state, we can see that both accounts now have one wrapped BTC in their balance. Additionally, we can proceed to make a cross subnet transfer. So starting from this address, sending to the other subnet. So in order to specify a cross subnet transfer, we need to prefix the address with the target destination subnet ID. And as we previously created an account on that subnet, we can specify that target address. We can specify to send one BTC, so essentially the whole balance of this account. So we are going to be prompted whether we are sure to execute this transfer. After confirming this, when printing the state, we can see that the account balance got updated, and additionally, the transfer was submitted to the post box. Additionally, we can also create a transfer from the other account. Where the destination address would be the same as before. And the amount can be half a wrapped Bitcoin. After confirming this, we can see that both balances got updated and that we have both transactions to this. So in order to handle these transfers that are in the post box, which are cross subnet transfers, what we need to do is run the relayer for this particular subnet, which is responsible for relaying these transactions and sending them to Bitcoin. We can run the relayer binary. And we can see that the relayer says that it handled the transfers for this particular subnet. And we can see that on the BTC monitor, this transaction got parsed successfully. We'll cancel the relayer so that checkpoints are not being submitted. And we can see that the account target got funded. If we take a look at the state of the subnet interactor, we can see that the post box is empty. And if we run the subnet interactor for the other subnet, we can see that the target address got 1.5 wrapped BTC from the transfers. Additionally, another important thing to mention is that after the relayer collected the validator's signature and submitted the transaction to Bitcoin, we can see that the balance of the subnet, because of the checkpoint transactions and the transfer transactions, got reduced from the amount that is left to cover for the transaction fees. Now we can move on to submitting a withdraw request. And we can withdraw from target. Let's say that we'll withdraw the whole amount. And we're going to be prompted with a confirmation whether we are sure that we want to withdraw 1.5 BTC from the subnet. After pressing enter, that is confirming. Then we'll get an address to withdraw to. Once we enter that, we can see that withdraw request was submitted to the post box. And if we print the state of the subnet, we can see that the withdraw is indeed in the post box. Another thing that can be seen on the subnet state is that the total withdrawable amount by users reduced from 1.5 BTC to 0. This is because the withdraw transaction is submitted to the post box, so the balances are accordingly updated. But the total subnet balance is not yet updated because the transaction has not yet been sent to the network. And similarly to how we handled transfers, this is the responsibility of the relayer to forward this transaction to the network after collecting the signatures of the validators. Another thing on the right, we can see the balance of the wallet, which the withdrawal would eventually, where the withdrawal would eventually end up in. So as we mentioned, in order to handle the withdrawal that was submitted in the post box, we need to start the relayer for this particular subnet. We can proceed to run the binary. And after running the relayer, we can see that the withdrawals were handled. We get a message that the withdrawals were handled in the post box. We can cancel the relayer. If we look at BTC monitor, we can see that the withdraw command was executed and then 1.5 BTC was withdrawn. If we take a look at the subnet state, we see that the total amount left to cover fees got reduced because it paid for fees for withdrawals, for handling the withdraw transaction. Additionally, the post box is empty because this transaction got handled, and that the total balance got reduced by 1.5 BTC plus some fee used to pay for the transaction. If we take a look at the user balance, we can see that it got increased by exactly 100 and some extra BTC. So 100 because 2 blocks were mined, one for handling the withdrawals, one for handling the checkpoint, so that's 100, and then 1.5 Bitcoin for from the withdrawal. We can now proceed to display the demo for the checkpoint transactions, and similarly to how withdrawals and transfers were handled, this is the responsibility of the relayer to periodically submit checkpoints to the Bitcoin network for a particular subnet. So in order to submit a checkpoint for the subnet that is open on the left, we can run the relayer. After running the relayer, we can see that the checkpoint transaction was submitted and that a block was mined. So on the BTC monitor, we can see that the checkpoint command got successfully parsed and that the checkpoint itself is matching the value that we see on the bottom. If we change the state in any way, like let's say add another account and then print the state, we can see that the checkpoint is modified. And then once a new checkpoint is sent, so a new checkpoint is sent for this subnet, then we can see that that change is exactly reflected on the Bitcoin side when parsing this particular transaction. Another thing to notice is that with every checkpoint we submit, we can see that the total subnet balance is reducing, and with that the total amount to cover fees is also reducing. So once a new checkpoint is sent, we can see that the total amount reduced. We can now proceed with the final workflow of the demo, and that is deleting a subnet. So we've already started a subnet interactor for this particular subnet. And if on the L1 manager we read the state, we can see that we have the 2 subnets that we previously created. By pressing 5 on the subnet interactor, we can see that we've submitted a delete request and to the post box. And as we previously mentioned with transfers and withdrawals, the relayer needs to take care of the requests in the post box. So before executing the relayer, I would like to display the user balance, which is around 2,380 Bitcoin. And what we expect as a result from the delete transaction is that the user gets the Coinbase transaction, and on top of that he receives the collateral back that they locked beforehand, and they also receive the total subnet, or the amount left to cover the fees from the subnet, as there is only one validator essentially. After submitting after executing the binary for the relayer, we can see that the delete was handled, and we can see that the delete command was successfully detected and successfully executed. If we take a look at the balance, we can see that it increased firstly by 100 BTC because there are 2 Coinbase transactions from the 2 blocks mined, one for the checkpoints, one for handling delete. And then on top of that, the user received almost 11 BTC minus some fees. If we start the Element Manager and read the state now, we see that only one subnet state is displayed.